My name is Ellen St. Romain, and I am the Elevation Program Specialist for the Texas Geographic Information Office. So I'm the project manager for this year's Lidar project. The Texas Water Development Board is trying to capture a really accurate picture of what's going on the ground. So what is where, and we fly airplanes to capture Lidar, and Lidar has different classifications to it. So we can differentiate between a tree that's tall or grass or bare ground or water or houses. And then it's not actually an image, it is a light return. The accuracy of the data that we capture is between 10 centimeters and 25 centimeters. So where the data is on the planet, we have a very high accuracy. So this project is unique. It is the largest project that the Texas Water and Development Board has acquired. So last year, the projects I managed, the largest project was about 7,000 square miles, and this project is 23,000 square miles, so over twice the size. And the plane in back of me is one of the two aircrafts that they're using to fly the 23,000 square mile Lidar acquisition. We're paying for some additional deliverables, so we're going to have 2D footprints of all of the buildings that fall within the project area, as well as 3D building models. It's also the first project that we used HUC 6 boundaries to sort of determine the project area, and that is important because other data types are using that as their standard. A HUC 6 is just a measurement of a watershed. The larger the number of the HUC, the smaller the watershed. So a HUC 6 is a pretty large view of a watershed, and historically our projects have been flown and determined by county boundaries and partners and where partners need Lidar flown. Now we are moving to this HUC 6 boundary system, and it's just going to be a more uniform standard that we are setting. Having the boundaries of a project area be HUC 6 based versus county based is really valuable because, ecosystems spread across county boundaries. The 23,000 square miles we're flying in this project kind of lay between Dallas and Austin and Abilene, and the area was selected because the USGS Lidar refresh cycle historically has been every 8 years. So their standard is we want to refly areas every 8 years. That standard recently changed to every 5 years. So we have a lot of ground we need to cover to maintain that refresh cycle. The data that we acquire for all of our projects historically has been used for things like dam safety, emergency evacuation planning, so understanding when it floods and it floods 20 feet in different areas, where do we need to send resources, where do we evacuate people? So the Texas Water and Development Board uses it for lots of different planning purposes. In addition to that, all the data that we house on our data hub is free to the public to access. So other agencies will download it and use it. Texas Parks and Wildlife uses it for different feature extractions or habitat analysis or change detection analysis. So seeing between the last Lidar collection and the current Lidar collection, what has changed in the landscape, like what buildings are new, what ecosystems have been impacted. It's really valuable for flood analysis and understanding how water moves across the landscape. The options are kind of limitless, and we're also learning more and more that we can do with it.